Welcome to Chapter 8, Lesson 4, Multiple Representations of Functions. That is a fancy way of saying that we're going to take a function, which looks like an equation. We're going to write it as an equation. We're going to write it using a table, and we're going to write it drawing a graph. All three showing the same equation. So take a look at this question. It's about school lunches. And so you're going to be purchasing lunches and they cost $3 a piece. So we're going to write an equation to find T, the total cost of all those lunches for a lunch pass with N number of lunches. We don't know how many lunches we're going to buy. That's why it's a variable N. So let's draw a picture. If this represents a school lunch, that would be $3, right? If we have another school lunch, that would be another $3. So if this was how many school lunches we'd buy, our N, our number of lunches, would be 2. Okay? The T would be the total cost. So for this example, the total cost would be how many dollars? It'd be $6. So we want to write an equation so we know it's going to have an equal sign. And the total cost is going to be T. But now we need to put an N on this side to show the number of lunches. Since each lunch costs $3, what will be our coefficient or our number that goes in the front? It's going to be a 3. This way, if you buy one lunch, the total cost is $3. If you buy 2 lunches, the total cost would be $6, just like up there. So our equation is T equals 3N. What you need, Clyde? Go ahead and get through. Buzz on through. Now let's take a look at the same equation as a table now. Okay, so there's our table. And we're going to fill in the function table to show the relationship between the number of lunches and the total cost. So if we just had one lunch, what do you think would be our total cost? $3. What if we had 2 lunches? So that would be N equals 2. What would that total cost be? $6. What if we had 3 lunches? So now N equals 3. What would that total cost be? $3, $6, $9, $9. So as you can see, we took our equation, T equals 3N, and we now made a table to show that relationship. Now we're going to show what it looks like on a graph. So we're going to keep this information on our function table. And then we're going to put it in a graph. So this means that number of lunches is along the N axis, which is our bottom axis, and the total cost T is on the vertical axis. So this means we're going to go over 1, up 3. Over 1 lunch, and the cost is $3. If we have 2 lunches, that cost is $6. 3, 6. So over 2, up 6. If we buy 3 lunches, the cost is $9. So over 3, up 9. And if we had 4 lunches, what would that cost be? 3, 6, 9, 12, right? So our graph would be a line. And if we had 0 lunches, of course, that cost would be 0. Okay? So that's how we graph the ordered pairs. Now we need to analyze the graph, which means write a sentence about it. Well, what's our graph doing? If we connect the points, okay, so we know that the graph is a line. That's pretty easy to tell. And we go over 1, so you go over 1, and then if we go over 1, we go up how many? 3. We go over 1, up 3. Because why? Because each lunch, oh, speaking of lunch, it's 1 o'clock, hope you had your lunch, because each lunch costs $3. So go ahead and read this. And that's how we analyze the graph. We basically tell what the graph is doing and why it's doing that. Okay, so that is how we take all these 3 parts, the equation, the table, and the graph, and show the same function just in multiple representations.